By the end of class today, I want you to be able to put numbers called integers in order and also be able to determine something called absolute value. So hopefully by the time you walk out of the door today, you can put numbers in order. Yeah. Numbers in order, and then determine something called absolute value. Okay? Corbin, can you close your Chromebook so I can see your face? All right. So, the opposite of a number is the same distance from 0 on a number line as the original number, but on the other side. 0 is its own opposite. So if I asked you, what is the opposite of 4? Well, -4. What's the opposite of 5? -5. What's the opposite of 7,000? -7,000. What's the opposite of -5? 5. What's the opposite of 0? There is no -0. It's just 0. It says right there, 0 is its own opposite. So the opposite of 0 is 0. That was kind of a trick question. Well, that's pretty easy, isn't it? All right. 4 and -4 are opposites. All right. So on your homework, you're going to have a question. What's the opposite of 2? -2? It's a lot easier than it was before. Now, number lines. This is what the trickiest part of negative numbers are. You have to picture them on a number line. All right? If you only saw everything to the right of 0, if you only saw everything over here, okay? If you only saw everything over here, and this didn't exist, this was crossed out, you never existed. It never existed. You know that as you move that way, or to the right, as you move to the right, the numbers increase in value. They are worth more, correct? And as you move to the left, as you move this way, the numbers decrease in value, or they are worth less, correct? Yes? You with me? All right. Well, the same is true on the other side of 0 on the number line. The same is true. The further you move to the left, the less value they have. They are worth less. Even though the numbers appear to be increasing. -1, -2, -3. Even though they look like they're getting bigger, they're not. They're actually worth less. Think about it this way. Think about the negative number in front of it as owing money. Okay? The further or the bigger the number, the more money you owe, so it's actually like worth less. You see what I mean? You want to be farther to the right. They're worth more. Zero is neither positive nor negative. Okay. Integers are the set of whole numbers, not parts of numbers, not decimals. They are whole numbers like 1, 2, 3, 4, 5, and -1, -2, -3, -4, -5. They are whole numbers. They are not parts of numbers. They are whole numbers. By using integers, you can express elevations above, below, and at sea level. Sea level has an elevation of 0, meaning if you're standing there on the beach at the ocean, you are at 0. You are 0 feet above sea level. You are 0. Okay? But as soon as you start walking away from the beach and you start going up, away from the top, away from the water, the higher above the water, the higher your elevation is. That's positive. That's above sea level. Now, if you walk down into the ocean, you'll start dropping below sea level. Okay, and there are actually places in the world that are below sea level that are still on land. Death Valley in California is an example. It's actually lower than sea level. So if somehow we had a river from the Pacific Ocean to that valley, it would fill up with water. Anyway. Whole numbers are the counting numbers and 0. 0, 1, 2, 3, 4. Okay. So you are going to be asked to do questions like this. Graph the integer -7 and its opposite on a number line. Oh, okay. So all you have to do is you have to make a number line. I would start with -7 because that's the smallest, least value. -7, -6, -5, -4, -3, -2, -1, 0, 1, 2, 3, 4, 5. Uh-oh. I'm going to run out of room. 6, 7. Okay? All you got to do is put a dot at -7 and put a dot at 7. Yeah. A lot easier than finding surface area of a prism, isn't it? Notice, -7 has the least value. It's the furthest to the left. And we go negative, it's a countdown until you get to 0, and then you start counting up. Okay? Would you rather have -$7 or -$5? -$5, that means you like owe $5. Remember? Okay, so we're thinking about the further to the left you go, the less value they have. All right. Next one. Why don't you guys do this on your whiteboard? It's really easy. Draw your number line. -5, -4, -3, -2, -1, 0, 1, 2, 3, 4, 5. Big dot here, big dot here. Beautiful. Which one's the alligator going to eat? 4 or -4? 4. Boom. This is not absolute value. We will get to absolute value. Think about it. Think about it. A lot of you are going to look at that and go, here, this is a speed bump. Okay, we talked about speed bumps. Okay? You guys are going to look at this and you're going to, oh man, this is so easy. It's so simple because it is. It's very easy, and you're going to start going too fast because that's what you guys want to do. You want to go fast because you want to get on to the next thing, and you're going to look at that and go, oh, 15 and 9. Boom! That's not right. Would you rather owe $15 or would you rather owe $9? I'll take 9. Okay? Let's not get into politics. Okay? You have to put $1 in the jar. Oh, we're not doing that. Someone say less than or greater than. Think about it. Greater than. Remember, greater than looks like that. Less than looks kind of like an L that's flat. You're also going to be asked to put them in order from least to greatest. You're going to have to, I believe, it'll give me a number line. Okay, so you get a number line, you draw a number line. I would start at the smallest, I would end near the biggest. Well, they decided to go all the way up to 8. Could have stopped at 6 if they wanted. Okay, so it says use a number line. Remember, follow the directions, Kennedy. Okay, it says use a number line. So you are being asked to draw a number line. You draw the number line, and then you're going to put them in order. So what's our smallest value of all of those right there? The one with the least value. What? -8. So you'd put a dot at -8. We got that one taken care of. What's the next smallest value? Cody. -5 is my next smallest value. It's right there. What's my next smallest value? Brett. -3. It's right there. My next smallest value is 0. It's right there. Next. Kennedy. 2. And last is 6. Okay? That one's not too hard. Now, the last thing I want to talk to you about is something called absolute value. Absolute value is its distance from 0 on a number line. It's just a distance from 0. And since distance can never be negative, absolute value can never be negative. They are always positive or 0. Okay? So it's basically absolute value means distance from 0 on a number line. So think about it. I told you it gets easier. The absolute value of -7. How far from 0 is -7? 7. How far is, what's the absolute value of -12? 12, because it's 12 away from 0. It can never be negative. So when someone asks you what's the absolute value of 5, it's 5. That's the distance away from 0. That's how easy this is. Absolute value is demonstrated by 2 straight up and down lines on each side of it. That question is asking, what is the absolute value of 8? 8. No, you don't. You don't have to demonstrate the number line. You don't have to do that. It's just showing that it's 8 from. So the answer is 8. Okay? So here's what you would do. Here's how you show it on your homework. Absolute value of -12. That's what I want you to write down. I want you to go like this. -12 equals 12. That's how you show your work. All right? Cody? Not too complicated for you, are you? Is it? Well, I don't think it would be that funny. Okay, what's the absolute value of 3? 3? Yeah? Okay. I think you can handle this. You do have a homework assignment. However, I know that it won't take you very long, and it's just a quick worksheet, and I bet you can get it done in class before you leave.